Hi, this video is actually going to cover synthetic division and synthetic subtraction. So let me show you the steps from the textbook, one of my textbooks on synthetic division. Let's see if this is, let me scroll that in and see if I can make that a little less blurry. There we go. All right, so let's look through these steps real quick, and then I'll show you a couple examples. So when you're dividing, you should have already watched my video on long division, and that method is great, but this method's kind of cool, so I want to make sure I showed you it. What it says is you take each term, 2, 7, and 9, or each coefficient or number, and you're going to put 2, 7, 9 here. Then what you're going to do is you're going to take the opposite of what you see. So I see positive 2, I'm going to take a minus 2. Then from here, what it's saying is you take negative 2 times the first term, or first number, so times these two, and write it down here, which is negative 4. And that's kind of your starting point. And then you add straight down. So this one becomes 2 because there's not a number here. And then 7 and negative 4 make 3. Then go 3 times negative 2 to get your next number here, which would give you the negative 6. Then negative 6 and 9 make 3, and this 3 is your remainder idea. So then we could rewrite this as 2x plus 3 plus the remainder of 3 over what you were dividing by, which was the x plus 2. So this is kind of how long division or synthetic division works. So let's do a couple examples from the book. Let's see, this one has, so let me scroll that probably back up a little here, or you're going to not be able to see my whole problem. Let's see. So this one has, because I got cords bumping everything everywhere. This one has 4x squared minus 12x plus 9 divided by x plus 1/2. So we're going to take each number here. So that would give us 4, negative 12, and 9. Then we're going to take the opposite of what we see here, and that's negative 1/2, and that'll be our number here in the corner. And we started by negative 1/2 times 4, which would give us, well, what's 1/2 of 4? 2. Opposite sign, so that'd give us negative 2. And then we add down. This one stays 4. Negative 12 and negative 2 make negative 14. Then negative 14 times 1/2, a negative times a negative is a positive, and half of 14 is 7. So I get positive 7. 9 and 7 make 16. Remember, the last number is the remainder part. So remainder, this will be the number by itself, so that would make this one an x. So the final answer is 4x minus 14 plus our remainder over what we divided by, which was x plus 1/2. Okay, so that is synthetic division. Let me see if, here's one that is a little bit longer, so just to make sure you understand it, where to put in the results. So what if I have x to the 4th minus 2x to the 3rd plus 3x plus 1, and you want to divide it by x minus 3. Alright, so something like this one. We want to take each number, so this time we have 4, and then we have the plus 3 over here, so 3 is going in the corner, and then we're going to use a 1, and then a negative 2, then a 3, then a 1. So we'll start with 1 times 3, right? Would give us our first spot over here, which is 3. Bring down the 1, I get 1. Negative 2 and 3 make 1. 1 times 3 is 3. 3 and 3 make 6. 6 times 3. 6 times 3 is sometimes 18. I don't know why I couldn't think of 6 times 3. Did I mess that up? I think I did. Hold on. I think I just messed up on my example. 3 times 1 is 3. 3 is 1. 1 times 3 is 3. 4, 3. Ahaha, I see where my mistake is. Hey, this was a great way to mess up because this is what you will be doing. I guarantee it. Even in long division, see how it goes fourth power, third power, then we're missing the x squared. That's what I'm missing here. So hang on, let me grab a new piece of paper, cover this up. I'll show you what I'm missing. So we had the 3 over here, and that's great. We know this is a 1. We know this is a -2, but we don't have an x squared, so we have to actually use a 0 like a placeholder. So mine weren't lining up right because I didn't have that placeholder. So if something doesn't turn out right, and my guess is you needed that to count down. Fourth power, third, second power, x number. Sorry about that. Well, no, I'm not sorry because it's a perfect place for me to mess up. So 1 times 3 is 3, and we already got this one, which was 1, and then bring down that one. 1 times 3 is 3. 3 and 0 make 3. Then 3 times 3 is 9, and 9 and 3 make 12, and then 12 times 3 is 36. 36 and 1 are 37. And remember, the last one's your remainder. So then I count like this way. For my answer to try to put it back, it's kind of weird, right? We got all these random numbers. This is always the C value or the number by itself. So we know that's going to be 12 plus 37's our remainder over what we divided by here. Then the next term will be our x, so it would be 3x. The next term would be our x squared. It's going to be a 1, and the next term is x to the third. We started with a fourth, and then it went third, second, 1, number, remainder. So that's pretty common. Okay, so we have to make sure we put in the placeholders. What else? So the same kind of idea, I know I want one more example I wanted to give, is using subtraction. So synthetic subtraction or substitution. I shouldn't call it subtraction. So substitution. So here is the idea of this one. If you're given that p of x or f of x or some formula, maybe I have x to the third minus 4x squared plus 3x minus 5, and it asks to evaluate it for, I'm running out of room over here, so I'll just write it down here, x equals 4. What they're asking you to do is see what you get for an answer for plugging in the 4. And we can actually use this synthetic substitution to solve that. So the way that we do that is we put the 4 as our corner number, and then we put our numbers out. 1, -4, they go in order this time. 3, -5, I don't have any placeholders. 1 times 4 is 4, so this one brought down is 1. That one's going to be a 0. 0 times 4 is 0. 0 and 3 make 3. 3 and 4 make 12. And then 12 and -5 make 7. No, I couldn't do that one. This actually ends up being your answer. So that's what f of x, or when f is 4, you get 7. Input, output, domain, range, right? Oops, sorry. Input, output, domain, range. So when you put in 4 for x, you get 7 for y. Let's check that. Let's put the 4 in. So if we went and put it back into our original formula right here, put the 4 in, I'd have 4 to the third minus 4 times 4 squared plus 3 times 4 minus 5. 4 to the third is 64. So we have 64 minus, you got to start with the square on this next term here. So 4, why do I keep doing that? So sorry. It's like off the screen. Okay, so I plugged in all my numbers. So I have 4 to the third is 64. This is my next term here, and I have to do the square first. So 4 squared is 16, and then 16 times 4 is going to give us a 64 in that term right there. Okay, then bring down this plus sign. 4 times 3 is 12 minus that 5. Now 64 minus 64 is 0. What is 12 minus 5? It's going to give me 7. So I got the same answer by substituting in the 4. Or I can use synthetic substitution, use the 4 here, and simplify, and your remainder spot is your answer. So you can, I'd like you to try both of these when it tells you. So try both synthetic methods when you're doing this, and also try long division when you're doing these as well.